Consider a scenario in which an object in either state A or not in state A. The likelihood that an object stays in its current state or moves to the opposite state is shown in the transition matrix, so right there. After an object has gone through one transition, its state vector is that guy right there. So U. What is the probability that the object was initially in state A? So basically, we can represent this transition with this matrix times this matrix equals this matrix. So we have 0.1, 0.7, 0.9, 0.3. Okay, I'm going to multiply that to xy, and that's going to equal 0.56. and 0.42. Now, this is one of those situations where A and, like, I'm giving something that looks like this. A times B equals X. And so what I need to do is I need to inverse A, multiply it to both left sides so that crosses out, and then B equals A inverse X. So since I'm allowed to use a calculator for this one, that's exactly what I'm going to do. I'm going to run to my calculator. I'm going to call you A, and you are now X, and I'm going to find out what A inverse times X is going to equal, and that will help me come up with an answer. All right, so I'm doing A inverse times X. So what I'm going to do is I'm going to create an inverse called A by doing second matrix, and I'm going to edit A. A is a 2 by 2 matrix, and we were given 0.1, enter, 0.7, enter, 0.9, enter, and then 0.3, enter. Now that I have this done, I'm going to quit out, and I'm going to create a new matrix to represent my X matrix. So I'm going to second matrix, and let's just call X C or D. I'm already at D, so let's edit D. Let's edit D. Why not? That matrix was a 2 by 1, so a 2 by 1, and that matrix was 0.58, enter, and 0.42, enter. Now what I need to do, and let's quit out of this, is I need to find A inverse D. So go to second matrix, select A, and we're going to do the inverse button, which is U. We're going to multiply this to second matrix 4. Hit enter, and we get the points 0.2 and 0.8. So let's go back and see what that means. Okay, so when we initially created this problem, the X and the Y, X meant the probability that it would stay in state A, and Y would be the probability that the object would not be in state A. We ended up getting the matrix 0.2, 0.8. Now, the probability that the object was initially in state A has to do with X. So X being 0.2, which means the probability was 20% of the object being in state A. So, tricky problem, very difficult, but we did it.